Okay, part two of today's lesson is dedicated to the idea is x plus x equal to 2x. And the algebra person in us is probably saying, well, duh, of course it is. But the statistician, of course, as usual, is saying, well, that depends. If you're talking about independent random variables, this is not true. We cannot add standard deviations and get a total standard deviation. And the same is the case if we had independent random variables of more than 1x. I'm sorry, more than 2. We can say the same issue. I can't just add them up. I need to use a Pythagorean theorem of statistics. So we're going to look at a situation. I'm going to use roulette for this example. Roulette has an average loss of 5 cents per dollar bet. Every time you play roulette, if you bet $1 on red or black, you are going to lose 5 cents on average per play. So the standard deviation then is pretty highly varied because the nature of the game, it's about $1, almost $1 that you can vary. So quite a bit of variation. If we play twice, then the mean is easy. We would just say that the expected winnings is just 2 times negative 0.05. So negative 10 cents per play. Yeah, that's pretty easy. But standard deviation, I can't just add up 0.998. That's not what the Pythagorean theorem of statistics says. So even though I'm combining with itself, I still need to do 0.9986 squared plus 0.9986 squared and square root that. That'll give me my standard deviation. So in that case, if I grab my calculator real quick, the square root of 0.9986 squared plus 0.9986 squared gives me about $1.41. That's my standard deviation. If I do this 3 times, then I can do the same thing with the mean. 3 times 0.05 means about a 15 cents loss is what I would expect. And the standard deviation, now, even though this is the Pythagorean theorem of statistics, I can just keep going as many times as I'm combining. So we would say in this case the square root of 0.9986 squared plus 0.9986 squared plus 0.9986 squared. And just keep going as many times as you need. So if you wanted to take this further and say 30 times, well, then 30 times negative 0.05, no big deal. You're expecting to lose $1.50. And standard deviation, obviously, I'm not going to write this all out. So I think about the standard deviation is going to be the square root of 0.9986 squared plus 0.9986 squared plus ... as many times as I need to. Well, to simplify this, that's going to be 30 of these. So if I try to represent that a little bit simpler, it's going to be the square root of 30 times 0.9986 squared. So I can go to my calculator, the square root of 30 times 0.9986 squared. And I would expect a standard deviation about $5.47. So that's how you combine many random variables together. I'm going to have you take a look at this page about oranges and repairs, let you give it a shot, and then pause this video and check your answers. Okay, you had a chance to check it out. Hopefully you got the mean of this probability distribution is 33, and the standard deviation is 4.58. So the variance is 20.976. So if you have 50 trees, just multiply 33 times 50. Boom, there's your mean. Mean is always easy. Shouldn't second guess yourself on that. And we're assuming that if each tree is independent, that we can use the Pythagorean theorem of statistics 50 times. So 4.58 squared plus 4.58 squared plus 4.58 squared 50 times that you do that addition. And so you should have got 32.39 oranges. Don't forget your units to do this in context. Here's the repair question. Final answer on this one should have been a mean of 13.6 calls and a standard deviation of 2.55 calls. Hopefully you got it. And if you have any questions, don't forget to reach out to your statistics teachers to have them help you out.